We physicists have held up a long time starting around 1916 for this photo. Welcome to Astral Explorer, your door to the universe. Black holes are one of the universe's most mysterious and fascinating phenomena today. They are huge, strong, yet imperceptible Goliaths sneaking in the murkiness of room. However, the work of renowned physicist Michio Kaku has provided us with an unprecedented glimpse into their nature, and as a result, we may now have a better understanding of what lies within a black hole. Go along with us as we investigate the profundities of room and uncover the privileged insights of these infinite titans. Before we dive into Kaku's pivotal discoveries, how about we start with the nuts and bolts? Dark openings have intrigued researchers for more than 100 years. However, a significant number of us have an overall thought of what a dark opening is. There's still a great deal of disarray around them. In his theory of general relativity in 1916, Albert Einstein predicted the existence of black holes, but at the time, these theories were only theoretical. It was only after the 1960s that researchers tracked down the primary genuine proof of a dark opening. They saw an X-ray emitting bright blue star while studying the Cygnus constellation. Upon additional examination, they understood that the star was circling a huge item that wasn't noticeable. The X-rays were being dragged into a vast, unseen object. That is the point at which the expression dark opening was authored. This disclosure was huge. It demonstrated that dark openings exist past Einstein's wild hypotheses. The black hole, which is now known as Cygnus X1, is approximately 6,000 light-years away in the constellation Cygnus. It's multiple times the mass of the Sun and has an unimaginably solid gravitational force. Truth be told, it's strong to the point that not even light can get away from its grip, subsequently the name dark opening. However, the unpredictability of black holes is what truly makes them terrifying. When something comes too close, it is pulled in and will never come back. This secret has ignited many years of examination, yet researchers actually had little thought what lay inside these astronomical monsters. As of recently, following the discovery of Cygnus X1, researchers began their search for additional black holes. It turned out that the Milky Way alone may contain 100 million black holes. These items are very difficult to identify, which is the reason we've just tracked down a small part of them in our system. There are probable large number of dark openings, each holding mysteries about the universe. This makes reading up them critical for how we might interpret space. One steady remaining parts: gravity. The immense gravitational pull of black holes is the most mind-boggling aspect of them. Anything that crosses their occasion skyline gets sucked in, packed to a close limitless point known as a peculiarity. In more straightforward terms, dark openings resemble enormous vacuum cleaners. They swallow everything in their way. The scary part is that a person would not simply vanish if they fell into a black hole. They would get extended into a solitary line, an interaction called spaghettification, before they even arrive at the peculiarity. It's not a pleasant course of action. Fortunately for us, the closest dark opening to Earth is around 1,500 light-years away, so until further notice, we're protected. In any case, it truly does make you ponder. Might a dark opening one day at any point represent a danger to Earth? In 2021, the logical world was dazed when the very first clear picture of a dark opening, explicitly the M87 dark opening, was delivered. Researchers caught it north of a few evenings, consolidating endless photographs to make a more clear picture. It was shocking to learn that black holes are not simply vast expanses of nothingness. This new understanding has opened up a world of possibilities regarding what lies beyond the event horizon because they have three distinct layers. Michio Kaku as of late uncovered that we may at long last have a brief look at what's inside a dark opening, a disclosure that could change how we might interpret the universe for eternity. You need to endure the initial two layers. The point of no return is referred to as the event horizon in the first layer. There is no turning back once you pass the event horizon, and you will be sucked into the black hole. It just deteriorates from that point. The photon sphere in which light travels around the black hole is the second layer. The gravitational pull of the black hole will ensnare any light that enters this region. At long last, we come to the third layer, the peculiarity. This is where all that enters the dark opening gets compacted down cosmically until it turns into a peculiarity. The peculiarity is a point in spacetime where the laws of physical science, as we probably are aware, them separate, and we can't foresee what occurs straight away. The laws of physics cease to apply when the density reaches an infinite value at the singularity. What exacerbates this limitlessly is that each dark opening you study is not quite the same as the last. Indeed, they follow a similar three-layer idea, yet their way of behaving can fluctuate incredibly. Assuming this were anything more, we could simply concentrate on the issue exhaustively. However, with dark openings, you can't do that. Researchers can concentrate on dark openings by implication by noticing the radiation they emanate and the gas and residue that encompass them. Anything that enters the event horizon is pulled toward the singularity, where it is compressed into an infinitely small point, making it impossible to send a probe like Voyager inside a black hole. You can't squander billions of dollars on a test just for it to be squashed into nothingness once it gets excessively close. Along these lines, researchers are passed on to concentrate on dark openings in a two-layered manner, despite the fact that they are three-layered peculiarities. To make matters really testing, each dark opening is one of a kind, and the laws of physical science separate inside them. As a result, black hole research is beyond the scope of conventional scientific methods. However, this does not preclude researchers from trying. There are a lot of theories and explanations for black holes, and things get more and more interesting with each new discovery. The idea that black holes are formed by collapsed stars is one of the most convincing theories regarding their formation. At the point when a star debilitates all its fuel, it can never again create sufficient energy to check gravity, which continually pulls internal. The star then collapses in on itself, shrinking and becoming denser. In the event that the star is sufficiently enormous, this breakdown can go on until it turns into a peculiarity. To more readily comprehend dark openings, NASA researchers directed their concentration toward the center of the world M87. Stargazers noticed a super-strong whirlpool of superhot hydrogen gas turning at a shocking 1.2 million miles each hour. The power of this turning gas ought to have made it fly separated, yet it didn't. Researchers concluded that there must be an enormous mass gathered at the focal point of the system to keep it stable. There is only one possibility for this massive object, which weighs between 2 and 3 billion suns. However, that is not the only black hole theory. A spinning black hole was first described by New Zealand mathematician Roy Kerr in 1963 using Einstein's gravity equations. Kerr demonstrated that a spinning black hole would not disintegrate into a point but rather into a thin disk or ring of fire. The circle would turn so quickly that radiating powers would hold it back from imploding. The ergosphere is the region around the black hole where the laws of physics begin to break down, and this spinning disk of matter. The fact that Kerr's solution predicted the existence of an Einstein-Rosen bridge, also known as a wormhole, was its most intriguing feature. This is a hypothetical entry through spacetime that interfaces two separate districts of the universe, or even two equal universes. That's what the thought is. If somebody somehow happened to fall into a dark opening, rather than being squashed, they could be sucked down a passage through the ring of fire and shoot out of a white opening in an equal universe. To comprehend how this functions, we want to take a gander at the idea of spacetime in Einstein's hypothesis. In Einstein's hypothesis, existence are not discrete substances but rather are interconnected, shaping a four-layered texture called spacetime. Objects with mass twist this texture, making a gravitational field that makes different items push toward them. Now, picture a piece of paper that depicts spacetime. In the event that you put two focuses on the paper and define a boundary between them, this addresses how items travel through spacetime. Be that as it may, imagine a scenario in which you could overlay the paper 50 and make an easy route between the two focuses. The basic concept of a wormhole is that it is a shortcut through spacetime that instantly connects two points that are far apart. Wormholes are a prediction of general relativity and not just a sci-fi idea. In any case, nobody has at any point noticed one straightforwardly in light of the fact that wormholes are innately shaky and would implode very quickly. If there is an Einstein-Rosen bridge, black holes could be more than just cosmic vacuum cleaners. They could also serve as access points to other parts of spacetime. All in all, might we at some point utilize a wormhole to go through reality? Sadly, the response is likely no, basically not yet. Regardless of whether we could settle a wormhole, it's far-fetched that we could utilize it to travel quicker than light. Einstein's hypothesis of exceptional relativity predicts that the speed of light is as far as possible on how quick anything can go through spacetime. Be that as it may, the hypothesis of wormholes and dark openings as pathways to different pieces of the universe, or even to various times, has been a subject of interest and theory among physicists for quite a long time. If we are successful, the concept that there could be shortcuts through the fabric of spacetime that would enable travel over great distances or even into the past could be revolutionary. The Kerr wormhole, in honor of mathematician Roy Kerr, is one of the most intriguing ideas in this field. He originally portrayed it utilizing Einstein's conditions of gravity. This sort of wormhole is basically a speculative passage through spacetime that could interface two far-off focuses, like two unique universes or even two distinct times inside a similar universe. Similar to the Kerr wormhole is frequently depicted as a ring-shaped portal. Popular concept of a stargate that could theoretically be used as a passageway. The Kerr wormhole is a fascinating concept for future space travel, even though it is still a theoretical idea. We might be able to instantly traverse vast universe distances or even travel backward or forward in time if we were able to stabilize and travel through such a wormhole. However, scientists are still attempting to determine whether or not it is even possible to construct and maintain a wormhole. In the vicinity of a black hole, the physics laws begin to break down, and conventional scientific research methods become less reliable. In any case, that doesn't mean the idea of wormholes ought to be excused. All things considered, numerous hypotheses once thought to be incomprehensible, like dark openings themselves, have ended up being genuine. In the end, the groundbreaking work of Michio Kaku has made us more aware of what lies beyond a black hole's event horizon. However, there are as yet numerous unanswered inquiries. Might wormholes at some point be utilized for time travel or to investigate far-off worlds? Inside a black hole, what happens to the laws of physics? One of the most exciting frontiers in physics is the search for information about black holes, though these mysteries remain unsolved. With each new disclosure, we draw one stage nearer to opening the privileged insights of the universe. In this way, remain tuned to Astral Explorer as we keep on investigating the universe and uncover the responses to the greatest inquiries in the universe. Thank you for watching, and keep looking up at the stars and remaining curious and inspired.